All right. All right, so we have our participants rolling in, and it's 3 o'clock. All righty. So, ladies and gentlemen, welcome. Welcome. We are, thank you for joining today's webinar. We are presenting this breaking weather event, Hurricane Ian, with Dr. Kim Wood, Associate Professor at the Department of Geosciences in Mississippi State University, and moderated by meteorologist Chris Vagasky. So this, folks, is a first in what AMS Weather Band is planning as a series of webinars that focus on important late breaking weather events as they occur. Our intent is not really to give you the current conditions and predictions that you might find on a weather broadcast or a website, but instead to give our viewers a look at the science and various uncertainties or variables behind each highlighted event. We are hoping to give you a peek behind the scenes, if you will, of what is happening as we lead up to these major weather events. But before we begin today, I would like to address some of the ground rules for our webinar. If you have questions during the webinar, please put them in the Q&A option at the bottom of your Zoom screen. We will not be looking at the chat, any submitted chats. We want to focus all of the questions on the Q&A because that way our guests can keep track of the questions that you have and answer them as they pop up or at the end of the presentation. Any questions or comments submitted through the chat option will not be considered. We will also have some specific time, like I said, for questions from the audience after the interview, but as the guests see fit, they may answer it during the presentation as well. So first, I would like to introduce you to today's moderator. Chris, thank you very much for joining us today. Folks, Chris Vagasky is a meteorologist and solutions manager for North America at Vaisala Incorporated, where he has worked for more than 5 years. In his roles, he has helped support Vaisala's North American customers and sales teams in matters related to upper air measurements and lightning data applications. Chris holds a bachelor's degree in operational meteorology and a master's degree in applied meteorology, both from Mississippi State University. He has previously worked in Oklahoma City as a weather intern, storm tracker, and fill-in meteorologist. Chris is an active member of both the American Meteorological Society and the National Weather Association. Chris's weather interests relate to how meteorological measurements can improve weather communication, new applications of lightning data, and weather preparedness and lightning safety. So with that being said, Chris, the floor is yours.
All right, thank you, Gideon, and thank you to all of you who are joining us. And my background is a little different than my background normally would be. I flew to San Francisco today for business, and I'm sitting in my hotel room. But let's get to the topic at hand here. We are dealing with a very significant hurricane threat to the Gulf Coast of the United States with Hurricane Ian. Just about an hour ago, the latest advisory came out on Hurricane Ian, putting the winds at 100 miles per hour as the storm continues to strengthen south of Cuba. And we're expecting continued strengthening over the next several days as Ian approaches Florida. And we're really going to dive in today into maybe some things that you wouldn't normally see on a typical weather broadcast or even on some of the more in-depth broadcasts that we've been seeing on the Weather Channel lately. And so I wanted to think about who would be a really good person to speak on Ian and provide maybe some additional insight you may not normally get. And my mind went straight to Dr. Kim Wood at Mississippi State, Hail State. And she is an associate professor there. She received her bachelor's of science degree at Oregon State University before going on to the University of Arizona, big Pac-12 girl, where she got her master's and PhD. Very interested in tropical meteorology, been into hurricanes for as long as I've known her and even before then. And her interests lie in tropical cyclone intensity, the structural evolution of tropical cyclones, and some satellite-based methods of tropical analysis. So I think we're going to get a lot of really interesting details about Ian and the tropics in general from Kim today. So Kim, thank you again for joining us.
Well, thank you for taking the time to host this, to arrange it, to invite me, and to do all this from a hotel room as opposed to the comfort of your own home or office. So thank you very much for that introduction. I am going to jump into some fundamentals and then kind of build from there based off of the types of things that I look at as both a scientist and a communicator. So I do encourage questions. I am using a web browser in part so that hopefully you can pay attention to the URLs that I am showing here, which you can then access yourself, either during this, if I'm getting too boring for you, or after the fact. I'm starting with the National Hurricane Center page because this is the official guidance. They are the experts who are distilling all of the information out there that you might be seeing flying around on social media behind the scenes. They look at everything they possibly can to create their advisories, which come out every 6 hours. For those of you in the Eastern time zone, that's at 5 and 11 a.m. and 5 and 11 p.m. And then when there are active watches or warnings in place, such as if you click on the forecast cone and you see coastlines outlined, then they also issue intermediate advisories in the intervening 3 hours. So that would be at 8 a.m., 2 p.m., 8 p.m., and then again at 2 a.m. So those intermediate advisories are active when there are watches and or warnings in place. So the first thing that I do after visiting the NHC page is go to the forecast discussion. Now, the forecast discussion tends to be full of a lot of jargon, but it generally has 3 main components. A brief summary in this first paragraph that talks about the current state of the storm and how they know what they are estimating for its current intensity. So we've been in a great position lately to get a lot of aircraft reconnaissance. That's when aircraft fly into the storm with all kinds of sensors on board, drop dropsondes, which are generally, if not always, coming from Faisala. And yes, we even have a prop. And as they go through the air, they're taking measurements and sending it back to the plane, which then transmits it back to forecast centers to be disseminated for analysis and for also for people to geek out over. They also will talk about in this first paragraph information they get from satellites. So we look at the structure of these storms and infer information about their intensity based on their structure. We know that once tropical cyclones start to form an eye, that's around 55 knots, it starts to clear. When you see that on infrared imagery, that's an indicator of the strength of the storm. So we use patterns like that via the Dvorak technique to infer how strong a storm is if a plane has not recently measured it. Now, those techniques have become more and more refined over the years. Efforts at SIMS and elsewhere have put in incredible amounts of effort to refine and make sure it's a more objective technique so that it's consistent over time and a more reliable tool. That second paragraph is about what's going on around the storm. What might the conditions that they're seeing where the storm is and where the storm is expected to go do to the future of that storm? So you notice that they talk about additional intensification during the next 24 hours or so, very warm waters, we'll get to that in a little bit, and also they mention shear. Then they start talking about different timing. It's going to reach Western Cuba early Tuesday morning, and then cross that relatively low elevation part of Cuba. So there isn't a lot of land to disrupt it before it reaches the Gulf of Mexico. And then after that, we've got some complicating factors. So this is where, yes, they're talking about the intensity, but you don't necessarily want to pay attention to just the number that we give to the storm. The category is just one tiny element of what is currently characterizing a storm. They also, in this paragraph, will give some information about how their forecast, their values line up with different types of guidance that they use to come up with these numbers. The final paragraph is about where's it going to go. So we had an intensity discussion. Is it going to strengthen, weaken, that sort of thing? And then we have a motion discussion. And that's really important too, because where it goes and how quickly it gets there has an effect on both what is the environment it's in going to do to it, such as the warm water it traverses or how quickly it enters an area of higher shear, but also the speed at which a storm approaches a coastline, as well as the angle at which it approaches a coastline, affects the impacts then realized at that location. And that's one of the reasons why there's a lot of concern for the Tampa Bay and surrounding areas. It's because of the direction the storm is currently expected to go and the speed at which it will get there. So if you imagine yourself blowing across a bowl of water, the longer you blow on it, the more water you move. If a storm takes longer to approach a coastline, that's more time for its winds to push water toward that coastline. And if that coastline's pretty flat, doesn't change elevation much as you gain distance from the actual water, then that's farther inland inundation that becomes possible. So storm surge is a huge concern for what Ian is expected to do as far as its motion and its intensity. Something that NHC has been doing consistently in more recent years are these key messages. So if you get lost in all the jargon that's happening up here, the key messages are the place to go to figure out, okay, they figured out some stuff about what the storm's going to do. What does that mean for me? What does that mean for somebody I know who lives in the path of the storm? So this gives information about timing, about hazards, and also it can talk about durations, such as key message number 4, that Tuesday is when rainfall is going to increase. In fact, I saw some reports today about heavy rain already falling in parts of South Florida, which is going to pre-saturate the ground, which would worsen the freshwater flooding impacts from additional rain that falls in association with Ian. But they note that it spreads northward Wednesday and Thursday. So this is a prolonged rain event. So there is going to be a lot of days where rain is falling from the storm, and how long that rain lasts depends in part on how quickly the storm moves. So that's why paying attention to storm motion is going to be important. So that was a lot of text. I definitely like to communicate with graphics whenever possible. So this is the outlook from the Weather Prediction Center about how much rain is likely to fall over a period of time. So this is valid from about when that latest advisory for Ian was issued through about 5 days later. So this is a 5-day accumulation, but that doesn't mean that it falls over the entire 5 days. This incredibly high amount of rain here, that's going to fall while Ian is there. And that's going to happen over a shorter period of time. But it gives you a sense of over this period of time, how much rain could fall. And at least for now, the highest amounts are remaining offshore. So that's a good thing. But we're seeing widespread amounts of at least half a foot across much of the Florida peninsula. Here's the search. So if you didn't know, about a foot of water can float your car. So when we see inundation levels exceeding 5 feet across a large area, that is hugely concerning. Water is heavy. I don't know if you've ever picked up a gallon of milk or water, but you generally probably don't want to carry that for too long. Well, when you have a lot of it coming in all at once, that has a lot of momentum, a lot of force behind it. And if you've seen any videos from the recent surge that impacted Atlantic Canada from post-Hurricane Fiona, that water can come in really quickly. So not only may it be a lot of water, but it may come in at a fairly rapid rate, which is why there's so many counties currently under mandatory evacuation orders. We want people to get out if they can before that water even gets there, so that they are not at risk of being endangered by that potentially quickly rising water. When they talk about storm surge levels, these feet values, that is amount of water above dry ground. So if you're standing in one of these locations close to the shore and the ground is dry, then look up above you, 5+ feet. That's how high they think the water could get. So seeing 10 feet of water above dry land, that's a lot of water. Part of the reasoning for this has to do with the direction that the storm approaches. Part of it has to do with how long the storm takes to move across the area. Let me shift over real quickly to a map. So sorry to completely change gears here, but this is a map of the wind field that was estimated not too long ago for Hurricane Ian, informed by satellite and aircraft observations. So this is from CIRA out of Colorado State. And so you see here that the strongest winds are on the right side of the storm, and that the storm, it's the extent of tropical storm force winds, so 40 miles an hour. It's pretty big. And then we've got this concentrated air where the area where the strongest winds are, which is how we get that category, that intensity value. But you may notice here on the right side of the storm, the winds are pointing kind of upward from the south to the north. Well, if you then point that back at the Florida Peninsula, if the storm is trekking in this direction, then that means those winds are almost pointing directly at land. So they are in the unfortunately optimal position with that type of track to push more water on shore. Another big factor, though, isn't just the direction the winds are going, but how big the storm is. The bigger the wind field, the more area of ocean surface being affected by those winds, and the more water gets pushed on shore. It gets worse for this particular location because of the shape of the ocean floor leading up to the coastline. So in this Google Maps image, we see the shallow continental shelf that is west of the Tampa area and all of Western Florida. And that just allows more of that water to get pushed on shore because it's such a gradual and already shallow area underwater. That geography, both of the coastline itself and of the ocean floor leading up to it, can exacerbate surge when we have the configuration that is being forecast for the incoming hurricane. Now, I want to point out this graphic. This was actually tweeted about not too long ago by Allison Wing out of Florida State. And I was really happy that she drew attention to it because it is an often overlooked resource if you're trying to figure out what types of risks could be at play for your area or for an area where you know somebody that you want to help them out in how to prepare. So this is the Hurricane Threats and Impacts graphic from the National Weather Service. If you go to weather.gov/SRH/tropical, you will have a bunch of tabs, and this is the Threats and Impacts tab. And there are 4 different threats that they discuss with an interactive map, so you can zoom in and out. It overlays the most recent forecast cone and the different threat levels. So this illustrates tropical storm force winds, then gale force winds, hurricane force winds, and then the extreme wind warning criteria, which is greater than 110 miles an hour. So we see that the Tampa area is currently at risk for the strongest wind category. But if we zoom out, almost all of Florida is at risk for at least tropical storm force winds at this time, partly due to the expected size of Ian, partly due to the expected track of Ian. We can also look at the storm surge threat for the same area. And if I toggle back and forth between these, I want to highlight that a lot of areas outside the cone are at risk. The cone only follows the center of the storm. It does not account for the size of the storm, and the size often, if not always, once we get to the really narrow part, extends outside of it. Very small storms would have to be at play for it to stay inside this cone in, the early part of it. And Ian's not going to be small. That's one of the concerns about its impacts, is it is not expected to be small, especially if someone's thinking about a previous experience with something like Charlie. Charlie was a small storm. Ian's not going to be. So if we look at the storm surge threat, we see that, again, it extends outside the cone, and that most of that threat is either inside the cone or to the right. So when we say right of track, we're talking about if the storm's moving this way, it's on that the right side of that line being drawn by the path that the storm followed. And right of track is where the wind is pointing the same direction the storm's moving. And that's, as I talked about with the surge, that's why you see the extent of surge impacts so far extended outside the cone, because right of track is where that tends to be the biggest concern. One of the, I don't want to say intriguing because that makes it sound like I'm interested in it or something. This is all awful. I'm not excited by these impacts any means, but it is interesting to see that almost the entirety of the east coast of Florida, actually no, the entirety of the east coast of Florida is under some risk of surge, despite being on the other side of the peninsula. Because again, the storm is not a point. It's once its winds reach the other side of Florida, merge over the Atlantic, they're going to start pushing water in the Atlantic Ocean. And that results in a risk of surge for the east coast as well. The third entry on this threats graphic, this tool, is that of the rain. And so we again have multiple categories, and those impacts can extend outside the cone. This is not as quantitative as the rainfall map I showed earlier from WPC. So for information about how much rain there would be, that's where you would go. But at least this gives you a quick idea of what is your threat level. Is it more a localized concern, such as in the yellow, or is it we're going to get so much rain, we expect there to be flooding? And
Kim,
so once
I'll stop you, or I'll pause you for just a second here, because a good question did come up regarding these threats and impacts graphics. And that is, what period do these graphics cover?
That is an excellent question. And I am going to click on the FAQ page, which apparently produces a PDF that it's asking me to download, which you probably don't see. But that is one thing to keep in mind, is that these are just for the whole event. So the storm surge threat, for example, the threat to Tampa Bay is going to occur sooner than the threat for Jacksonville, because the storm has to then traverse the peninsula and get there. So this threat would occur temporally after the threats down here. If we go back to the map of rainfall, we see that this is over the entire period. But again, the rain over here is going to fall while Ian is over here. And then the rain downstream is going to occur later. So in this type of graphic, for more information, it can be useful to go to WPC. It's not in my bookmarks. No, there we go. And if we go to, there we go. So this is a day one outlook. And now you can tell I don't come here very often. There we go. That's the page I was looking for. So here is a 1 day total to get a sense of, okay, over this 1 day period, that's how much rain would fall. And then you can look at day 2 and see that, okay, that's where most of the rain is going to fall in the day 2 time frame. And then we see day 3 still raining here, but now that rainfall is starting to extend across the peninsula and into the Atlantic Ocean. So for a breakdown for some of that day-to-day timing, there are resources, but unfortunately in that threats graphic that we've been working through, they're trying to cover the entire event. And so they haven't broken it down by time. One place you can go to learn more about timing, though, is the arrival time of winds, which is one of the many graphics that's available on the NHC webpage. And so we see here that we've got the shading to represent the likelihood of experiencing tropical storm force winds. And then we have these contours that indicate the timing of when it will start, meaning you want your prep to be done before that line reaches your area. So for Tampa, that's tomorrow night at the latest. You don't want to still be prepping to leave or in the process of leaving if you are trying to evacuate, for example, or if you're boarding up your house. You want all that prep to be done by 8 p.m. tomorrow at the earliest, according to this graphic. So there are places to get more information specific to your area regarding timing, but they are not encompassed by these particular graphics. Thank you so much for bringing that up.
Yeah, thank you for that answer. And I think one thing that we are going to get into, but it's something that I noticed while you were going through some of these graphics, and I think it's going to be important that we talk about that during this this session, is just how much Ian is forecast to slow down.
Yeah, that's still a big question mark because it has to do with the timing and location of the trough that gets it out of here. How does that trough evolve, and how does the storm interact with it? That's why it's fantastic that we're getting additional balloon launches across much of the United States, is that's giving us more information on what the upstream flow is doing, so that we can then A, have that for our own analysis, and B, give that information to the models so that they are more likely to capture what is possible for that flow to evolve into, because we have a better sense of what it's doing now. So moving a little bit into the forecast, this is a very complicated plot if you're not familiar with it. So I'm just going to touch on a couple of things. What it shows is using SHIPS, which is a tool that informs how we expect a storm to evolve, and it's grabbing environmental information. So let's focus on this lower right panel, where this line here is indicating how strong the guidance that SHIPS model thinks the storm will be, and that corresponds with the right axis over here. So that's peaking as a Category 4, 120 knot hurricane. And then the x-axis down here is time in hours relative to when this came out, which was 2 p.m. Eastern today. So we see that there's this expectation of intensification to level off, and then pretty rapid weakening over the ocean. So before it hits land, that storm's starting to weaken. And one of the components for that is this green line here, which corresponds with the left y-axis, and that is relative humidity in the mid-levels. So a tropical cyclone is powered by deep convection, those thunderstorms. Thunderstorms need moisture to exist. If there is not enough moisture, they start to evaporate. Evaporation is a cooling process. If you've ever sat in front of a fan on a hot day with something damp nearby, that helps cool you off. Well, that might feel good for us, but a hurricane does not like air cooling around it. And that also interferes with the ability of air to rise, because cold air sinks. If you've ever opened your fridge and felt your feet get cold, that's an example of those thermodynamics at work. So a decrease in moisture tends to lead to a less conducive environment for a hurricane to maintain a high intensity. So we see that early on, a little bit of decrease in moisture, not too bad, but then, here it's leveling off and then starting to weaken as that moisture continues to decline, as the air dries out. Then we've got this kind of pale gray line here. That's vertical wind shear. So that's a change in either wind speed or direction with height. A tropical cyclone is most efficient when it's nice and vertically stacked. And if there's wind shear, that vertical stacking starts to tilt. So air travels a longer distance to gain the same altitude. It's less efficient. And so that also often translates, especially for strong storms, into a situation where it can't maintain that intensity, it starts to weaken. So the fact that we've got at the same time a decrease in moisture and an increase in shear, that is why there's this explicit forecast for weakening while Ian is still over water, even though the sea surface temperatures are ridiculously high. That's what this horizontal kind of salmon line is, and that's at around 30 degrees. That's 86 degrees Fahrenheit. That's bath water. That's plenty of energy for a tropical cyclone. So the factors to be watching is the change in moisture on the storm and the change in shear, which has to do with that trough that we are expecting to come in, interact with the storm, and hopefully help it move. But again, that timing, could be problematic for getting it to vacate quickly. Quickly touching on sea surface temperature, since that gets talked about a lot for these storms. Gulf of Mexico is toasty. These shaded values indicate, compared to average, how warm it is, and nothing's below normal. Great. And we see on average in this box, which is what the line plot shows, it's also above normal. So this blue line is where it should be on average, and the black line is what we've observed in 2022 so far. And this area right here, that's again above normal, is approximately where Ian is expected to move. So the sea surface temperatures not expected to get in the way of the storm, meaning they are not expected to contribute to its weakening. And even if it does move slow, at least in the southern part of the southeastern Gulf of Mexico, there's a lot of warmth. So this is looking down. So up here, the top of this y-axis, that's the surface of the ocean. And then we start descending thanks to these robots. They're Argo floats. They take profiles of temperature and saltiness of the water. This is showing the temperature, and we see lots and lots of warmth, pretty deep. So as a tropical cyclone moves over water, it's pushing that water that I talked about with the surge, but water rises up to replace that pushed out water. And if the water rising up is also really warm, it's not going to change sea surface temperatures much. It's not going to change the amount of energy available to the storm all that much. So kind of getting back to that big question of what's the storm going to do? The fantastic Tropical Tidbits website here. This is showing one model. So this is a possibility. This is not what's going to happen. So I show this hesitantly as an illustrative example of what could happen, but it's one possibility. Pay attention to the official NHC guidance for actual what is going to happen. So looking up here, we see that this was initialized 8 a.m. Eastern today, and then this particular map is looking out 30 hours ahead from that. So about so tomorrow afternoon. We see that the storm has crossed Cuba and still looks pretty intense. There's a lot going on this map. The big things to watch for are sort of the shapes, the flow features that we have going on. So these lines have to do with what's going on in the mid-levels, what sort of structures are in place, and then the little barbs are the upper level winds. And so that helps characterize this feature to the north of Ian to get a sense of what might that look like according to this particular run of the GFS model, and what might that do to Ian's motion. So if we click forward in time, note that I just went ahead another 30 hours and Ian didn't move a whole lot. It did move, but it didn't move a lot, and it slowed down. Each intervening step, it covered a little bit less distance. So that's indicating a slowdown of its forward motion. We're not talking about slowdown of the winds. We're talking about how quickly the storm is moving. And then I hate this. It just sits. So again, this is just one possibility. This is one model run, one deterministic run. This is not showing the ensembles, but it does highlight what could happen And in this particular instance, we see that this trough up here didn't quite grab it. And so that was a contributor in this particular possibility of that storm slowing down. So this is the thing to be watching. How does that trough end up coming in, and how does it interact with the storm? A better way to look at things, I hope it works because I closed the tab earlier, is looking at a whole bunch of squiggles. Okay, before I click on this is just a whole bunch of possibilities, and there's none of them are necessarily the right answer. They're just giving us a spread of what could happen depending on slightly different starting conditions. And I'm going to just go to here because I don't like looking at models more than 5 days out unless there's some signal I am specifically investigating. So what we're seeing here is differences in how that trough ends up interacting with Ian depending on which model. So we've got the so-called Euro over here, the European suite of ensemble members and a whole bunch of squiggles. And then over here, we've got the GFS version of an ensemble with a whole bunch of squiggles. The colors has to do with how strong each member thinks the storm will get. But a really useful feature here is this black line, the average of those. And so we see really good consistency between the two for the first 48 hours and then spread. So this is highlighting confidence, not this is what it will definitely do, but based on this range of scenarios, it's pretty likely that this storm's going to keep gaining a component of northward motion. And then after that, really depends on how that flow to its north evolves. So that's really important to be watching. How does that flow evolve? And that's why those additional observations upstream over the US are going to be so important alongside all of the aircraft that have been flying through it. All right, that was a whole lot about like the models and whatnot.
Yes, that was a really great in-depth look at the kind of the background and kind of what is impacting Ian right now, what is Ian impacts going to be. I think some of the attendees here, and we have almost 100 attendees, so there's a great audience here, and they've kind of picked up on what meteorologists would consider as analogs. So I've been seeing some comparisons to Hurricane Charlie, which impacted the west coast of Florida, and even the 1921 hurricane that made landfall on Tampa Bay. Are you seeing any kind of similarities with respect to those two storms in Ian? Or as meteorologists, we kind of look at analogs because it's similar patterns, and you can kind of get an idea of what may happen by looking at some of these patterns. But do you see any similarities between the Ian and Charlie, or Ian and this other really famous landfall from 1921?
So I will admit I didn't look at data for the 1921 storms specifically because I was focusing on Charlie because we have more data for that one. So I'll go ahead and jump over to that. So this graphic I made to help indicate over time how has Ian's intensity evolved and how has its size evolved. So we've got time here on the x-axis. Here on the left y-axis, we have how strong it is. So that corresponds to this maroon line. Can you blame me for picking maroon? And then over here on the right y-axis, we have how far out do the tropical storm force winds go? So that corresponds with that timing graphic I showed of the start of tropical storm force winds. So that's what's here in blue. So we see that as Ian has intensified, it has also gotten bigger. If we go to Charlie, we see that it stayed about the same size as it intensified, and this peak here is about when it made landfall. So after making landfall, it very quickly weakened. But Charlie was a small storm. So it's the greatest extent of its tropical storm force winds was about 110, 120 miles. Whereas Ian's already almost at 120 miles. So this is one of the components that we're watching for those impacts, is how big is Ian going to grow? And if you're comparing to Charlie, it's already getting bigger. So Ian is still south of Cuba. It has not emerged into those incredibly juicy waters of the Gulf of Mexico. It hasn't finished its intensification trend. So it is likely to continue growing. Something else I want to point out, this is Hurricane Florence. So this is a much longer time frame, but we see its first rapid intensification and then rapid weakening. But look here, as it weakened, it got a lot bigger because the momentum doesn't just disappear. That outward evolution of momentum, that flux of momentum outward from the center where the winds were so strong, that often broadens the wind field. And we see that as it intensified the second time, it got a lot bigger, a lot bigger, a lot bigger. So Florence was weakening as it approached the North and South Carolina coastlines. But because it was massive, it drove a huge surge on shore. And again, it was pointing in a direction that maximized the ability of that wind field to push water on shore. So a concern is that Ian will get big as it intensifies and then get bigger as it weakens. And even though it is weakening, its maximum winds are going down, its surge threat will still be strong alongside a strong rainfall threat. So we cannot pay attention to that category. Like, it's a good place marker, but it is not going to encompass the types, the full extent of the threats. Ian may be a weakening storm at landfall and still be driving forward a 5 to 10 foot storm surge in places. So I wanted to highlight Florence here, even though it made landfall in a very different location and underwent a different evolution, because it was weakening on approach to land and still devastated a large area with storm surge and with freshwater flooding due to heavy rain.
That kind of leads into this next question here. You showed it in Charlie and you showed here in Florence, and we've been talking about the potential for this with Ian is rapid intensification. And I think, as meteorologists, Kim, you and I as meteorologists, we understand that rapid intensification is a challenge for forecasting and for modeling. Do you have a way to kind of describe just how challenging that is, and why it is such a challenge?
Well, let me show you Ian rapidly intensifying, and then I'll get into that. So here's an animation of the past about 36 hours. So here at the beginning, 45 knot tropical storm, we're going to watch it weaken a little bit and then intensify. So here is a blob of clouds. Honestly, this still image, you probably wouldn't even necessarily say that's a tropical cyclone. It is a blob of disorganized mess. But we watch it evolve into a more disorganized mess, and all of a sudden we see that pulsing. And those bursts of incredibly cold cloud tops indicating very, very tall clouds. So the colder the cloud top, the higher it is in the atmosphere. And thus the deeper that cloud is, that produces that high cloud top. And if they stay cold for a long time, there has to be a lot of rising motion to enable that to persist. Now, let me play that again. Actually, I'm just going to start looping it. So hopefully I don't mesmerize you too much here. But what you see here is that pulsing, and oftentimes some of the features are really small. And so when it comes to rapid intensification, a lot of the processes driving these changes are small in scale and short in time. And models can only capture so much detail in space and in time. That's what we refer to as their resolution. What can they resolve? And so sometimes we have to estimate things that are happening on scales smaller than what the models can resolve. And many processes leading to rapid intensification are occurring on scales smaller than those models can resolve. That's why some of the hurricane specific models that have very fine grid resolutions, really small time steps are so important to try to capture some of these processes without making estimates of what they're probably doing. These images are at 2-kilometer resolution from a satellite 22,000 miles above the Earth's surface. And we see that there's a lot of really small features that they're able to capture, but that a lot of those features don't last very long. So watching these cloud top temperatures in motion kind of helps highlight the small scales that we're trying to infer and trying to get our models to estimate to figure out what a storm will do. So we can get the environment pretty well, and we have a good sense of what environments tend to be conducive, but the storm itself has to cooperate, and those small scale processes have to occur in sequence, in tandem, almost like a dance. They have to follow the right order of steps for this process to then activate. I'm going to show one other one. So this is a side-by-side of 1-minute imagery. Actually, I lied. It's every 30 seconds because we have 2 mesoscale sectors currently taking scans. And so that enables us to just really get in at some of these small scale features. We've got visible imagery here on the left, which is at 0.5-kilometer resolution, the absolute best that we can get from our GOES East satellite. And then on the right is the same product I was showing in the previous animation. And so there's a lot of fine scale details that we can get out of this. We can see just these isolated, really, really deep cloud tops. They've got a little extra bubbly texture to them. We see that they're overshooting, and those correspond with these colder values over here in the infrared. But again, these are processes that we're trying to capture both with our science and with our guidance tools, and it's not easy to do.
And I think that really kind of goes into why it's so important that we get more and more data, and kind of the importance of, one, the hurricane hunters, and 2, the work that the National Weather Service is doing around the country right now. Because, as Kim mentioned, these are very small scale processes, and we're getting very small thunderstorms that are developing. And for us to really pinpoint that with the satellite, as Kim said, 22,000 miles away, can be a challenge. And as I showed the prop earlier, the hurricane hunters are flying almost continual missions into the hurricane right now, and they are using dropsondes like this that they fall through the atmosphere. We've got a nice parachute to kind of study it as it falls through the hurricane, but it's collecting all of that information. And as one of the things that Kim mentioned was the humidity in the atmosphere. So there's a humidity sensor on here to measure how moist is the atmosphere. There's a temperature sensor on there, so we know the temperature is the atmosphere as this falls through. Wind speed and direction, and the atmospheric pressure, so that we can find these really intense portions of the storm and get that really good handle on how strong is the system. And then in reverse is the weather balloon, the radiosonde, which 2/3 of the weather balloon sites in the United States right now are launching these 4 times a day instead of 2 times a day, so that we can better understand what is that trough that Kim was showing. What is that trough doing? How strong is it? Is it maybe going to pick up the hurricane as it moves? And Kim, I think you're going to show the satellite loop here showing that trough. And we can see, Ian is the very bright green, dark green area there, and the trough is in the dark blues and maybe some light yellows there. And so there's a lot of data being collected right now all around the United States and in the storm to really try and help us get a good handle on the intensities of both, and to feed the models so that we can answer some of these questions of, is the storm going to slow down? How strong is it going to be when it makes landfall? Is it going to go further north? Is it going to go further east? So there is a lot of work that's being done around the clock right now by meteorologists all around the country to really help us hone in on what is going to happen with this storm.
Yeah, this is a animation of upper level water vapor. So this is giving us a sense of the motion in the upper part of the troposphere. And we're using how much water vapor is present as a tracer. You know, if you dropped some colored dye in water and then watched it flow around, we're kind of doing that same thing here with how much moisture is present to track how is the air moving. And so we get a really good sense of how air's getting from one place to another, how quickly it's moving, the direction it's taking when we look at water vapor imagery. And when we don't have clouds, we get a sense of how moist is it. So if we've got these more like yellow colors, that implies that the air is a bit more dry. And as we get into this like pale blue, almost white, not quite to the clouds, then that implies it's more moist. And so we see that there's this trough coming in, but there's also this sort of barrier between them that is comparatively moist. So Ian hasn't reached that less moist air yet that we see over eastern Texas and Louisiana, but obviously it is coming down. And so this is the snapshot of what's happening now, but Ian isn't in the Gulf yet. It hasn't finished its intensification trend yet. And as a storm gets stronger, its structure changes, the depth of its vortex evolves, and so how it interacts with the flow is going to change. So that's why capturing what intensity it'll have does matter for where we think the storm's going to go. And again, as Chris was talking about, that's why those observations are so important. The more we know about the storm, the more we can understand what it might do next.
And we've got about 10 minutes here, Kim. You know, I reading through the questions that have been asked so far, and I think this question is a really good question. Since mandatory evacuations have now gone in place in Hillsborough and in Pinellas counties, and I think along some of the other counties as you go down the west coast of Florida. And it kind of speaks to some of the uncertainties in the forecasting. One, does the NHC have any say on evacuation orders? And two, is it maybe too early to start evacuations with uncertainty out there?
Yeah, so I'm going to speak to the second part first. When it comes to evacuation timing, once there's an order, people don't immediately leave. They still need time to put their plan into action. They still need to possibly fill up gas, grab groceries. They may have pets that they need to take care of, medications to handle. They may have family members that need additional help. They may just need to coordinate things, or, as they're trying to get ready to go, they realize that something's happened to their car. Maybe, there's a weird knock in their engine, or, something else equally terrifying. So it does take time from order being issued to actual departure. There's a lot of other things that need to get into place. Ideally, with mandatory evacuations, you've got housing centers for people to go to. You've got infrastructure that needs to be in place. For example, if they're going to do the counterflow and actually make all the lanes go north, you may notice that Florida is a peninsula. There's not a lot of places to go if you're evacuating, other than everyone kind of going the same way north. And so places that have more complicated logistics in departing may need earlier evacuation orders so that they can actually get out ahead of the arrival of the tropical storm force wind, which, as of the latest advisory, we're looking at, early to mid-evening tomorrow night. And so by having the orders out now, that's giving people 24 hours to figure out what they need to do and then act on it, assuming they have the resources. There's going to be a varied range of resources available to everyone. Not everyone has cars. Not everyone has the ability to just depart their homes. They may have more prep they need to do at home. Maybe they need to board up windows. That means going to the store and getting lumber. That means finding a way to then nail in that lumber to their windows to make sure it's protected. We saw the cascading compounding risks in the Tampa area from wind, from rain, from surge. So the extent of prep may require these evacuation orders to be issued fairly early. As far as who does issue, that is up to local governments. That's why there are so many calls going back and forth. As soon as a package is done, NHC is on the phone. They are talking with local partners. They are talking with emergency managers, city officials, NWS partners, all kinds of people, making sure to disseminate information that can then be localized by those who are local. And they also need time to figure out what do they need to do. So nobody's issuing an evacuation order lightly. And they have to have a sense of what is the timing that we need to look at so that they know when to issue it and also when to have all this infrastructure in place, who they need to activate to make things happen. So thank your local emergency manager, because they are absolutely essential pieces of this entire machine that is trying to protect as many people as they possibly can.
That is some really good information, and having never lived near the Gulf Coast, I haven't had to experience that. So I can only imagine, one, getting that evacuation order, and then two, trying to put into effect your whatever plan you have in place. The closest that I've come is potentially evacuating from a wildfire and trying to put that all into place right away when the wildfire was getting closer. Now, as we start to get towards the end of our time here, just to remind all of our viewers, where can you get the latest information on the intensity, the track, how fast is it going to be moving as it approaches, so that those resources are available, so that you can share that with your loved ones, family, friends that are maybe in the path of the storm.
So I'm going to go back to the main NHC webpage. It's not letting me click. I'll just do it that way. So here, this is the place to go. This is your first stop. If you're active on Twitter, you can follow NHC_Atlantic for a lot of this information as well. Their tweets will directly link to their latest advisories. The forecast discussion is the in-depth information. The public advisory gives a sense of where are the watches and warnings in place and what are some of the elements to be thinking about with respect to those. But I think for a lot of people, it's going to be the graphics. And so there's a whole bunch of different maps, but honestly, if your browser can handle it, I would go to the interactive map, because it brings everything together in one place where you can look at all these different products all at once. You can look at the earliest arrival of tropical storm force winds. And the font is not great, but hey, it's there. With this, you can zoom into a location of interest and get a sense of overlaying, what's going on. Again, if you're trying to share information with somebody, the static images can be better, but if you're trying to get a sense of what's going on and what are your risks, this is going to be the place to start. The other one was the risks. So the threats and impacts page has a lot of similar information. Again, as we talked about, it covers the whole event. It doesn't cover that timing element, but at least you can get a sense of where they're expecting, say, surge versus rainfall impacts to be higher or lower. And that's weather.gov/SRH/tropical. So those are my recommended 2 places to go first. Again, the National Hurricane Center is going to have the most up-to-date information on the current intensity, the expected changes in intensity, and the expected track. The cone is just guidance for where the center is going to go. The impacts can, and as we see often do, extend outside of that cone.
Well, Kim, thank you so much for taking the time to dive deeper into Hurricane Ian. I know you will be watching the storm over the next several days as it crosses Cuba and then approaches Florida. I really appreciate you taking the time to do this. If you want to share any contact information, like your Twitter account, so people can see what you're sharing about the storm, do feel free to do so.
Should I drop that in the chat or just speak it?
You could speak it, you could pop it up on the screen, you could drop it in the chat, whatever you think works best.
So my handle is Dr. Kim Wood. I try not to tweet too much, but when I see something that could be useful, something that could be relevant, something that gives context, I strive to do that. I like to link to resources like this threats and impacts page, but I also find it really important to highlight that the NHC is the place to go for the latest information. The one last thing I want to highlight is just how consistent their forecasts have been. This is all 15 of their official advisory cones. And we see that Tampa's been in them pretty much the whole time. And yes, there's other guidance out there. There's spaghetti models, there's social media, there's all kinds of things, but the experts are at the National Hurricane Center. They are distilling the information into something that they can be consistent with, that they've got procedures in place to then communicate that information to local officials, and they want to give the best information possible, and they work very, very hard to do that.
So there you have it, the National Hurricane Center, www.nhc.noaa.gov. That is the place to go for all the latest information on Hurricane Ian. Thanks to all of you who have joined us today for this really fascinating discussion. Thank you again, Kim, for all the work that you do. Always stay tuned for upcoming webinars, and you can join our AMS webinars mailing list. There was a link dropped into the chat there so that you can always be informed of when we do not just our traditional webinars, but these breaking weather type webinars like this, which again, we hope to do more in the future when we have impactful weather coming up, like hurricanes or winter storms or even severe weather outbreaks. So thank you all again. Enjoy the rest of your evening. And Kim, I'll let you go and have some dinner.
Thank you again for inviting me to do this and for the fantastic questions and discussion.
All righty. Well, fantastic. Thank you, Chris. Thank you, Dr. Wood. Thank you for everything. Ladies and gentlemen, they're still on here. We will make this video available to Weather Band members at amsweatherband.org and at amatsoc.org. Yes, thank you for joining us today, and take care, everybody. Stay safe. Bye. Oh, and Dr. Wood, go Beavs. I'm in Dallas right now. Yeah, we almost got the Trojans. We almost did. I was so, anyway, yeah. But yes, definitely go Beavs. I'll say hi to the campus for you.
Thank you.
Bye.
Bye.